Irrational solutions. In this video, you'll learn to use the radical and plus-minus symbols to represent solutions to quadratic equations. You'll also learn why the plus-minus symbol is used when solving quadratic equations by finding square roots. Square roots will always have two solutions, the positive and negative value. So if we have the square root of 9, then a solution would be positive 3 and negative 3, since both of those squared will give us a positive 9 under that radical. If a quadratic equation solution involves a non-perfect square under the square root, then the result is irrational, like the square root of 8 or the square root of 51. So let's look at some examples with these roots. We're going to solve each equation below by using the square root method. Let's start with our first equation of x squared minus 13 equals negative 12. We want to get the square term isolated so that we can take the square root of it. So we'll start by adding the 13 to move it away from the x squared. This will give us x squared is equal to 1. And now we can take the square root of each side, which gives us x is equal to positive and negative 1. Now let's look at our next equation. We'll start by subtracting the 9 from each side so we can get our square term by itself. This gives us x squared is equal to negative 9. And then we'll take the square root of each side. But when we look at the negative 9, anytime we take a square root of a negative, we'll end up with no real solutions because there's no value that when we square it will give us a negative. So now let's look at our last equation. This one already has the square term isolated, so we can start by taking the square root. This will give us x plus 1 is equal to the positive and negative square root of 18. Now we can set up the two equations where x plus 1 equals positive radical 18 and the other one is equal to the negative radical 18. So we'll subtract 1 from each side, and this gives us a radical 18 minus 1. In the next equation, we'll subtract 1 again, and we'll get the negative radical 18 minus 1. Here's another example. For the equation x squared plus 14x equals negative 46, the approximate solutions are negative 8.743 and negative 5.268. We'll find the exact solutions by completing the square. So let's take the equation they gave us, and we'll complete the square. Our first step is to find the term that will complete the square, so we'll take half of b and square it. Our b term is 14, and when we cut that in half, we get 7, and 7 squared gives us 49. So we'll add 49 to both sides of our equation, and this gives us x squared plus 14x plus 49 equals 3. We can simplify this to the perfect square of x plus 7 squared equals 3. And now we can begin solving by taking the square root of each side. So we get x plus 7 is equal to positive and negative radical 3. We'll set up our two equations, one equal to positive radical 3 and one equal to negative radical 3. We'll solve by subtracting 7 on each side. So we get that x is equal to radical 3 minus 7. And then we'll subtract 7 on the other equation, and this gives us the negative radical 3 minus 7. In this example, we're going to solve each equation using the square root method. Let's start with x squared equals 144. We'll start by taking the square root of each side, so we get that x is positive and negative 12. Now let's look at x squared equals 5. We'll take the square root of each side again, and this gives us x is equal to positive and negative radical 5. Since it's not a perfect square, we'll just leave it under the radical. Now let's look at 4x squared equals 28. We'll start by dividing 4 so that our square term is isolated. This gives us x squared is equal to 7. Now we can take the square root of each side, so we get x is equal to positive and negative radical 7. In our last example, we'll start by dividing by 7 so that x squared is isolated. We get x squared is equal to 16 over 7. If we take the square root of each side, then we'll get x is equal to positive and negative 4 over radical 7. The square root of 16 was simplified to 4, but the square root of 7 isn't a perfect square, so we'll just leave it under the radical. Now let's look at another example. We're going to find both values of the expressions below. So if we have 4 plus or minus 1, we'll have two expressions of 4 plus 1 and 4 minus 1. So this will simplify to 5 and 3. Now let's look at 10 plus or minus the square root of 4. We can simplify the square root of 4 to 2. So now we have 10 plus 2 and 10 minus 2. So we'll get 12 and then 8 and then 8. Now let's jump down to the bottom of negative 6 plus or minus 11. We'll set up our two equations of negative 6 plus 11 and negative 6 minus 11. This will give us 5 and negative 17. Now let's look at our last one. We have the 4 plus or minus the square root of 10. The 10 is not a perfect square, so we're going to leave it under the radical. So we'll have 4 plus radical 10 and 4 minus radical 10. And this is as simplified as we can get this one. In our last example, we're going to solve each equation by completing the square. We'll start with our first equation of x squared minus 10x plus 18 equals 0. First, we need to make sure that our constant is on the right side, so we'll subtract 18 from each side. This gives us x squared minus 10x equals negative 18. Now we need to find the term that completes the square, so we'll take half of b and then square it. b is negative 10, and half of negative 10 will give us negative 5. Negative 5 squared is 25, so we'll add this to both sides of our equation. This gives us x squared minus 10x plus 25 is equal to 7. We can rewrite this as a perfect square of x minus 5 squared equals 7. Now we'll move this up so we can start solving. We'll take the square root of each side, and this gives us x minus 5 is equal to positive and negative radical 7. So we'll set up our two equations where one is equal to positive radical 7 and one is equal to negative radical 7. We'll solve by adding 5 to both sides. So we get x is equal to radical 7 plus 5, and then when we add 5 to the other one, we get x is equal to negative radical 7 plus 5. Now let's look at our second equation of x squared plus 5x plus 1/4 equals 0. We'll start by moving that constant over to the right side. So we get x squared plus 5x is equal to negative 1/4. Now let's find the value that will complete the square. So b will be replaced with 5, and 5 halves squared is equal to 25 over 4. So we'll add this to both sides of our equation. We get x squared plus 5x plus 25 over 4 is equal to 6. We'll rewrite this as a perfect square of x plus 5 halves squared equals 6. And now we'll move it up so we can start solving. We'll take the square root of each side. So we get x plus 5 halves is equal to positive and negative radical 6. Now we can set up both of our equations. We'll start solving by subtracting 5 halves from both sides. So we get x is equal to radical 6 minus 5 halves. Now we'll do this on the other equation, and we get x is equal to negative radical 6 minus 5 halves. Now let's look at our last one. We'll start by moving the constant over. So this gives us x squared plus 8/3 x is equal to negative 14 over 9. Let's find the value that will complete the square. So we'll replace b with 8/3, and when we divide 8/3 by 2, we'll get 4/3. And when we square 4/3, we get 16/9. So we'll add that to both sides of our equation, and we'll get x squared plus 8/3 x plus 16/9 is equal to 2/9. We can rewrite this as the perfect square of x plus 4/3 squared equals 2/9. So now we'll move it up so we can start solving. We'll take the square root of each side. So we get x plus 4/3 is equal to positive and negative radical 2 over 3. We were able to simplify the radical 9, but the radical 2 is not a perfect square, so we'll leave it under that radical. Now we can set up our two equations where one is equal to the positive value and one is equal to the negative. We'll solve by subtracting 4/3 from each side. So this gives us x is equal to radical 2 over 3 minus 4/3. We'll subtract the 4/3 on the bottom equation, and this gives us x is equal to negative radical 2 over 3 minus 4/3. Now let's summarize what we've learned. Any positive number has two square roots, one positive and one negative, because there are two numbers that can be squared to make that number. When a number is not a perfect square, for example radical 40, we can express its square roots by writing radical 40 and then negative radical 40.